participants, they have complaint Shadi telling regarding Australia only. Then now dedicatedly for India. Okay? Thank you.
Can we start? Introduction of mine and Terry. I think we will start till the participants join. Good afternoon. I am Mike Agarwal, fellow Terry. I am a metallurgist by training from N90 Bhopal, and I can see here in N90 Durgapur two elements of N90. Yeah, it's good to be here. Thank you, Professor Mandal, once again. And we at Terry is
just a casual question. How did you get it, Terry? Like, what was the?
We gave it interview.
I'm like, you had a background in something sort of.
yeah. So I started my career with IBM from campus placement, and then I worked for 8 years in sales Bokaro Steel Plant as a production engineer. Then somehow I got this vacancy from LinkedIn.
It's better than sale.
Yeah, the exposure the daily gives is much wider than sale. I'm still working with sale. Few of our projects are with sale. So not only sale but with other ISPs also. We are in talks with JSPL, with JSW. We keep on organizing events where we collaborate with all the steel producers, policymakers, and peer group institutions, academy as well, for policy decisions or at various platforms for various reasons. So Terry, it was started in 1970s when it was felt that there is energy crisis, and people from Tata Chemicals found that we don't have any institution or any kind of organization was required. It was felt that we should how we can deal the energy crisis in future. So in 1974 it was started as Tata Energy and Research Institute, and it started working on energy related projects where it started collecting data. Then few publications were there like TEDI, annual reports were presented. Those were in public domain. Then in early 2000s, it was felt that now Terry has international presence and it has to be an independent organization. And then the Tata name was dropped and it became Tata Energy and Resources Institute. So since then, we are working in various domains, including air, water, energy, and sustainability, and many more. So we are at forefront policy making. We do policy research, policy advocacy in various fields, and we provide inputs to various ministries and departments of Government of India. We work with industry, we work with society to make world a better place, a sustainable place. This was the brief. And specifically in energy program, there is a division called Industrial Energy Efficiency. We work with industry, so we conduct detailed energy audits with the industry. We work with steel, we work with cement, we work with fertilizer companies, and whatnot, including glass, foundries. Then we design and develop technologies also in Firozabad cluster. We developed a furnace that is called Terry Bhatti there. When it was started when the crisis of existence crisis came with the stringent environmental regulations from MOEFCC due to Taj Mahal, and we developed natural gas bhatti, and people adopted that, and the industry could be saved in Firozabad cluster. Then diagnostic report, deep dive studies. We did deep dive study for Durgapur cluster, Sundargarh cluster. It is available in public domain. Then we do training programs, chemistry building programs, information dissemination. We do policy studies. Then decarbonization studies. We develop roadmaps for decarbonization. In 2020, we came up with the first decarbonization reason behind that is we do a lot of research with industry and stakeholders. We bring on together all the stakeholders and make these reports as practical as we can. So that everyone is on same page and we assess the situation right, and then we can say yes, this would be the roadmap. So this is how we work. Now, decarbonization roadmap. I saw in the previous session you have gone through decarbonization roadmaps for steel industry, but I think it will be different for India. And I want to know that what is the need of this decarbonization roadmap? Why we are talking about decarbonization?
Net zero,
In steel sector, it is already around 2.5 ton of CO2 per ton of steel we are generating. So obviously, what is another statement for decarbonization?
I think the process was much more emitting in early 19th century or late 19th century or 20th century, early 20th century, when the emissions were more than 5 tons of CO2 per ton of crude steel. I think it started way back. The story started way back from pre-industrial era, when carbon dioxide was around 220 ppm in the atmosphere, and with a lot of industrialization in the west and a lot of production, we are at around 450 ppm level. So with this 200 or 250 ppm increase in CO2 concentration in the atmosphere, we are seeing a lot of changes in the climate. The whole system of the earth is now disturbed, and it is estimated that by 2030, 1.5 degrees Celsius average temperature will rise on the earth. But recent study shows that we will achieve that target. It is not the right term, but yes, we will achieve this by 2028. So I think we have less time. With each degree increase in temperature, there are catastrophic changes that we are expecting in the weather, in the climate, and it is bad for humanity and mankind. So we felt that there is need for decarbonization of industrial processes, the way we work, and that's why we are looking for various decarbonization solutions. Now the things have gone much beyond afforestation and growing trees, because the fully grown tree exhausts at the max 50 kgs during its lifetime. So I don't know how many trees are required. So I think the story has to go beyond growing trees, and we are looking at our processes or way of building. So that's why we felt that there is a need for decarbonization roadmap. Now, when we are talking about steel industry in India, steel consumption is growing at around 7% CAGR. So our steel requirement will be huge. It is a question of balancing growth with the sustainability, or the how we will sustain. So this is a bit different than what West thinks. West has a lot of steel, legacy steel that they produced in 60s or 70s, 1960s or 1970s, that they are recycling with air, and their emission intensity is less. While in India, we need fresh steel because we are growing country. So our pathway will be different, the technologies are different, and the raw materials we have is much more different than what West has. So I think what Professor presented in the previous sessions, we have a little bit of difference in our roadmap. So it started in 2017 when National Steel Policy came. It gave the target that by 2030 we will have a capacity of 300 million tons per annum, and we will be producing around 255 million tons of crude steel. Despite COVID, I think we are on the track to achieve.
How 300 million ton of steel per
300 million ton of capacity and 255 million ton of production.
from now 2025 it is 140 ton and within
140,
152 million ton we have produced, right? Last year.
141.
141 was
So let's go 150. So within 5 years we will
Double.
get around another
the
100.
way
Double.
JSW, the Tata Steel and others are expanding. I
No,
don't
no,
think.
no, no. Why they are expanding? Mostly their takeover.
No. I mean, the 50 people from
I think
JSW,
sir,
they have
you will
25
better able to
million ton.
answer me.
Yeah, some are under investment stage and some plants are under construction.
Yes, and
So we need 5 years time to expand complete.
yeah, that is
How,
fine.
how much will increase the capacity?
Maybe about in Tata and JSW, JSK it may touch about 50 million.
50 million, eh?
50 million.
Yeah. And then
maybe
from
100 million.
capacity.
No.
50 million capacity in India.
You just told me that 50 million ton was last year.
Production.
Yes.
Yeah.
And Tata Steel and JSW together will go for another 50. Okay, in the upcoming years.
Yes.
So it will touch 200.
And what about JSPL?
All
They are
put
also
together.
All together, all
There are
together.
12 million, 13 million, 6 million, 4 million,
All
7
together.
million.
Vijayanagar, what I was told is that 4.5 million ton has been commissioned and now another 5 million ton is
No,
under,
here.
under planning in next 3 to 4 years. And
So 5 plus 5 is only 10
then
million.
another Dolby at Salem 5 million ton another capacity expansion. At Tata Steel Kalinganagar they are expanding by another
6 million.
5 to 6 million ton per annum. At JSPL they are aggressive. They are around 10 to 15 million ton they are expecting. Right. So
Arcelor
we-
Mittal 12 million.
ArcelorMittal is
right and
12 million.
sale.
12
See
million.
sir,
Sale.
Sale, not more than 10.
Look,
Sale
Sale,
was-
yeah.
Not more than 10 million ton. Not more than 10 million.
Maximum 10 million.
Not more than
and
10
what
million.
about the small players?
The figure won't touch 200 million ton.
Yeah.
At Arcelor 190 million ton is the current steel production capacity in the country.
Correct.
There is a difference between steel capacity and the
Production.
actual production.
That's what I am saying. I am saying that government targets 300 million ton per annum. I am not arguing on that. I am saying what government targets, and I think the way people are expanding, they will touch the production capacity. Maybe 255 million ton we will not produce in 2030, 31 year, but maybe in 2033, 34 we will be producing that, right? But the way COVID came and the production, reduced. I am not arguing on that point, but I am saying that despite of COVID, we are on the track to achieve that. Maybe 1 or 2 years later, it has been
Maybe a
very
decade from now.
yeah. So it has been discussed at length in task force meetings, and yes, people are ready to expand. AMNS the way AMNS is wants to expand. Although we don't know that how the things will work on the ground, but yes, we can see. I was not expecting that the capacity will increase or cross 180 million ton per annum by this year. But now I can see the JPC report. The capacity is 190 million tons per annum. We already have. So, and even the small players now they are integrating themselves. They are converting themselves into mini ISPs and then ISPs of million ton scale. So that's how industry is growing. In Durgapur cluster also there are many companies which are expanding into million ton scale plants, right? And
that is a little bit from where Wellness gone.
yeah. So here then in 2020 we launched this report achieving green steel, and green steel vision was then the work started on green steel vision by Ministry of Steel. Then the focus this time I mean in these 5 years will be on increasing the energy efficiency in the existing plants or existing units with various measures. Then from 2030 to 35 the focus may be on increasing the scrap utilization. As I already said that we have scarcity of scrap because we don't have legacy steel, and with the geopolitical situation I think it will be difficult to get scrap from international markets. Then green product standards. Yes, Ministry of Steel has taken step towards this. They at least have come up with a green steel definition. What will be there? They have classified the steel as 3, 4, 5 rated, star rated steel. Then I think India will be ready for decarbonization RD&D projects by 2030. I think more and then the things will move on according to the conditions.
So increase of scrap reduction is not in the plan right now because we don't have scrap.
See, it is in plan, but I think it is not.
It's not reality.
It's not reality. Of course, see, we don't have the legacy scrap mill. Everybody knows. People from industry are here.
In the roadmap there is a plan to increase the scrap reduction, but it's not possible.
It is from where scrap will come, sir.
It's not no, it was in the plan, but it's not possible. I am saying that.
See, once we start the plans, then we can explore the possibilities in international market. Then we can find the alternatives of scrap. Maybe DRI can be charged in blast furnaces. If we have green DRI, hydrogen-based DRI, or less emission-intensive steel or not steel but iron, then we can go towards this green steel. I think this could be possibility. And yes, government is focusing on increasing the scrap. Of course, vehicle scrappage policy came, although it didn't went off well, but I think it will pick up in some time. That's what we feel. Then coming to this policy framework, I think once the things start coming, then there will be a policy framework for deeper decarbonization. Rapid scale up of new low carbon technologies. I think this will start at around 2035, where the decarbonized technologies will start kicking in, and we can think of going off from blast furnace route, right? And then commercial scale facilities of these new low carbon technologies. By 2045 or 2050, we can start, thinking of discarding our older blast furnaces, or we may not go for relining, or we may not go for new blast furnaces altogether. And then with the integration of renewable energy and all other sources, by 2070, we are expecting that we will achieve net zero. And yes, during the course of time, by after 2050, our steel demand may also decrease, or the rate of growth may decrease, and we will have consistent demand, and then we can. That's how we think that we can achieve net zero in steel industry. Then government's initiatives towards decarbonization. We started with PAT scheme. All the big steel production companies are under PAT scheme. Then national steel policy came in 2017. Yes,
What is PAT scheme?
Perform achievement trade. Where perform achievement trade. Each 3 years in each PAT cycle, every designated consumer is given some targets to achieve the energy efficiency per ton product. Durgapur Steel Plant, ISP, all are under PAT scheme right now. Yes. They are different categories. Then
they have revised the version of PAT scheme, PAT scheme 1, 2, they have revised the version.
No, these are not versions, these are cycles, PAT cycles. PAT cycles. So, and see how unique this scheme is, there is no standard target for any of the plant or any of the unit. Each plant is working in its own way. So a baseline study is done, and on that baseline the targets are given depending on the potential of reduction. So it is different from what Europe thinks or what and how in India thinks.
So how much reduction is planned from 2015 to 2025? What was the plan and what is the
See, if you will see 2000 first PAT cycle came in 2012, right? A baseline study was done. Initially the targets were for reducing energy consumption by around 5 or 6%. Now they have reduced to 2% reduction.
And what was achieved in those 13 years?
Or
12 years, you
I
can say.
will cover all those things in my slides also. But to just give you an overall brief background, Perform Achievement Trade Scheme started to improve the energy efficiency. Okay, in the 12 it was launched, the baseline studies was done, and to reduce the targets was started from 2015 onwards. So each plant specific, they have over 13 specific sectors, and each plant is given a target to reduce their energy consumption.
My query was how much I was achieved.
So again, that tax cycle 1, 2, 3 results are also being published by the
Data is there.
PWD.
Data is there that how many
Million tons of
oil equivalent.
Yes.
And for each and every plant, data is available in public domain and consolidated data is also available. So you can browse.
So after every 3 years, whenever the plant study is being done, the PAT cycle studies are being done and they publish the data on the website. So if you go on the PW website, every detail is available that which sector has achieved how much million tons of energy oil equivalent.
If somebody has not achieved the target, then it has to purchase these energy certs. It's a market, e-cert market is there. So if one is achieving more, he has tradable certificates, and one who has not achieved their targets, they have to buy those energy certificates.
It started in India.
Yeah, it is going on since last 13 years. 13 years. So now it has converted into CCDST.
Just one figure I can give it. Each battery saved 1.59 million tons equivalent of energy. That is PAT 3.
For-
And PAT cycles 1 and 2 also, I don't have the MTOE, but 61 million tons of carbon dioxide. So those figures are available.
Yes,
It is publishing sector wise every PAT cycle whenever it is being compliant because it's a 3-year cycle. So PAT cycle 1, 2, 3 till 4 results are being still out. Now the ones which are under 7 and 8, those are being gradually transformed into CCDS because we have to introduce carbon markets.
So are we in line with the target? I mean, how much target we achieve? 80%, 90% or 100%?
No sir, there is not such kind of target. आप define नहीं कर सकते because sale this plant and what the one which is running in Punjab plant. This is the quite difference.
Actually, PAT scheme is not that much successful because the voluntary participation was not.
Yes,
got-
my
So
point
that
was
is why
that only.
compliances are coming.
And the
The
second
second
thing
is
was-
now MOEFCC has came into picture.
Now then there was like but the voluntary participation and the obligatory participants were also very less. So the scheme overall was a scheme, but it might have reduced something, but not very much successful as it was anticipated earlier. Now I think all the PAT scheme and all will be merged with the carbon market scheme. So
Yes.
I think Kapil can explain it better in the next session. Yes, government has taken right steps in right direction, although Europe or other Western world is moving away from those commitments. But still, India is on the right track, and whatever the Prime Minister has committed in the international forums, I think we are following that. Then vehicle scrappage policy 2021, where different scrappage centers are opened, although at any of the place they are not successful, but with the new regulations, then like fuel will not be available up for 15 years for old vehicles. This will promote scrap recycling. It is mostly scrap recycling industry is mostly in informal sector. So yes, everyone knows that scrap is recycled, but how much and in what quantities and what are the value chains, so those are informal. So I think the government wants to bring all these things into formal sector so that we have a good scientific way of recycling the scrap. Then PLI scheme for specialty steel to avoid imports of special quality steels. Although this has also not taken off well, but I think government has revised the PLI scheme again with the total investment outlay of around 29,500 crores. Then we have National Green Hydrogen Mission. In the National Green Hydrogen Mission also we have different a dedicated fund for R&D in steel industry, which is around 450 crores, and with the production of green hydrogen or green ammonia, we are expecting that some of the projects will start at least at R&D scale, and then those will be taken up further in the coming time. Then the hydrogen is available for steel because the quantity required in the steel industry is huge. So with 5 million ton, I don't think that sufficient quantity will be available for commercial scale steel production. Then electrolyzer manufacturing trench. Then we have green hydrogen production incentives, PLIs, and various schemes under National Green Hydrogen Mission. I'll give you an overview how the knowledge, we as a knowledge partners contributed to the task forces. This was divided into three parts. First is developing taxonomy for green steel, because defining green steel is very important. It has not been done by any other country in the West or in the world except India. Now we have definition. Definition is important for procurement. That what will be called green steel? Okay, the steel with emission intensity of 1.6 is called green steel, or emission intensity 2 or emission intensity of 0.8, because everything is possible in different steel production routes. Then CO2 monitoring. Now it is theoretical calculation based on WSM methodology, and it is driving its concepts from ISO 14067 standard. So how this monitoring will be standardized, and can we monitor these from stacks? All those possibilities were explored in this task force. And then demand generation, how the demand will be generated for green steel. Once the green steel is produced, then who will be the takers, and how much premium the market is ready to pay. And if the market is not ready to pay, then what will be the first mover's advantage? So considering all these factors, this demand generation task force was created, and it focused on these issues. Then energy efficiency, what is the status of current BAT's best available technologies in the existing plants, including ISPs and small scale SSIs. How much energy efficiency is possible in the current scenario, and how to achieve that, and how much budget is required to achieve this energy efficiency thing. Then renewable energy, if steel switches to renewable energy, then of course a lot of infrastructure will be required, maybe for green electricity production, as well as the transmission of this green electricity. Considering our steel production areas, geography, it is concentrated in eastern India, while the renewable energy is available mostly in western India. Rajasthan and Gujarat are most suitable for producing green electricity. And again, 24/7 renewable electricity is a challenge. For that, how we can handle this situation of this 24/7 requirement of the steel plants, where they need a reliable electricity. Then material efficiency, the ore quality in India is also a challenge, where now we are getting the average iron content in ore of around 60%, which is a challenge. It is deteriorating every day, and especially the people not having their captive mines, they have further lower quality ore material available. So how to tackle that? What is required? Maybe beneficiation, and what are the steps required? Then process transition. Is it a way that we can avoid stranded assets? Because every steel plant requires huge captive investment of the tune of around 6,000 crores per million ton capacity. biochar is available, in different quantities and different areas. And logistics is the most pinpointing challenge. With the increase in distance, the cost of getting biochar increases rapidly. So all those challenges were identified, and the potential solutions for these have been identified in biochar task force. Then RD&D, what is the budget required, how it will be done, what are the potential organizations through which RD&D will be done. For that, I think SRTMI has been revived by Ministry of Steel. Then financing, nothing is possible without financing. How this finance will be arranged, what are the finances available with the current players, and how government can contribute in financing, and what will be the role of key financial institutions including banks were discussed in detail. And the problem is huge with the small players who do not have much capital to invest in these new solutions, and they are unable to get finances of such large scale. Then international focus, how others are doing, and in what are the possibilities of collaborating with these international organizations, including academia and the R&D institutions. And in the Europe, the projects are funded by EU or the various governments, and the funding is up to 60-70%. While in India, the R&D is totally dependent on an individual player. All the funds available with R&D institutions are not educated to carry out these activities. So international focus is another area that was discussed in detail with various countries, that how they are moving. Then skill development. This is a question in this academic institution. The metallurgists don't have jobs, so they switch to software, and industry is saying that we don't get good metallurgists. So it's a vicious cycle. That kind of problem is there at graduate level, undergraduate level, at diploma level, and at ITI level. At all the levels, we are finding it difficult to get the required skill. And it was also explored that what are the key infrastructure requirements are there, what is available, and what is to be done. So all these things were assessed. A budget was prepared, and I think these are taking off in a well-structured manner now. A cabinet note has gone for this demand generation component, where budget is being decided and how the policy can kick off. It has been proposed that for 8 years, 5% procurements in public funded projects should be 5-star rated green steel. So it will be a motivation for steel producers to produce the 5-star rated green steel. Even with the higher cost, they can sell it in the market.
What is the current percentage of steel production through DRI route with respect to total steel production in India, and how much will it change in a decade?
I think it is around 54%. You can refer the JPC report. According to the latest JPC report, around 54 to 55% is from DRI route. And in 2030 national steel policy, 2017 national steel policy, by 2030 it is expected that blast furnace route will be 60 to 65%. So even now, I haven't seen any gas-based DRI new plant is coming up in India. All the expansion is going on blast furnace route, and even in coal-based DRI producers, either they are going for bigger DRI furnaces, or they are trying to get a small blast furnace, or whatever they can afford, or whatever their expansion are. So basically, the focus is towards blast furnace.
So the reason is the plan increase in way of food. What is the main reason for this?
Technology, proven technology, high capex.
High capex in DRI.
High capex. See, you have a risk. We don't have natural gas. In this region, CPM is available, but in what quantity? And the production cost is too high. coking coal chains. You know, if we are procuring, although we are vulnerable from the price point of view, but of course it is cheaper than natural gas. So from this perspective, I think the people are looking for, because whosoever is investing 6,000 crore rupees per million ton capacity don't want their capex to be in doldrums.
So phasing out blast furnace by 2050 isn't it a great challenge?
Of course, it is a great challenge. Let's say breakthrough technology comes. Let's say green hydrogen is available at 1.5 to $2 per kg. Then I think
Mr. Naushad, Professor Naushad yesterday was telling that in Australia they are targeting $2 per kg by 2030, I think. So where is India in that scenario?
see, you will see the National Green Hydrogen Mission targets. We are expecting green hydrogen to be in the range of $1.5 to $2 per kg by
Right.
2030. Right.
How is it
How is
possible?
it?
Before tax or after tax? It will take time. I think with the battery energy storage system. See, energy demand in growing in India is huge. Huge.
No, actually, my question is, one is theoretical aspect. We are discussing everything is theoretical, policies are being made. And what is the actual groundwork that is being done? Actually, we are still makers, we don't know. Question is from that point. We are still makers, we are operating blast furnaces, we are mostly process made. So I want to know where is the reality we are standing on right now.
See,
Because if you want to make some change, say if I want to go and tell my management, okay, the world is moving in this direction, India is moving in this direction, so we need to change our technology and we need to move in that direction. So what should be my point in discussion in that?
see, the way hydrogen projects are going on, right now there are different priorities. We don't have hydrogen storage infrastructure. We don't have technology to store hydrogen at large scale. We were importing electrolyzers. So the steps are in direction that okay, we will produce electrolyzers in our own country. We will have our own technology for storage. Because using hydrogen for these big scale projects, we need continuous supply. Then if pipeline transportation is possible, all these things are being done parallelly. And at this point, we have some electrolyzer manufacturers, L20, which has started now, which has started its factory. Then Reliance and Adani are other players. Coming to storage or transportation, Tata Steel, is there anybody from Tata Steel? Tata Steel recently filed a patent for hot rolled coil, which can be used directly for hydrogen transportation. So, with
What technology?
see, Tata Steel has produced, Tata Steel is now able to produce HR coils that can be used for hydrogen transportation pipelines. Right? So they had filed a patent for that. So that's how the things are moving with the government initiatives. If I think nobody has thought about this green hydrogen mission or something like that, then it wouldn't have happened. So things are moving. Although it may pick up in the coming time, the way solar projects are being awarded has changed completely. If you will see the trend in next 3 to 4 years, past 3 to 4 years, and compare it with other previous 3-4 years, then you will find that the scale of deployment has increased by a huge percentage. And the reason is the way SECI used to work, like for setting up a solar plant. The plant setters should have some land bank with them, but now this condition has changed. You have land bank, you can take the land bank from anybody, bid in the SECI tenders and start establishing the solar plants. So the scale has changed. The government has identified the challenges, whatever the challenges are, in the real time. People are working on that, and with this vision, I think even if it is not 100%, if it is achieved 50%, then it will be a huge energy production, green energy production, and subsequently achieving green steel, these are the key pillars that we identified in our roadmap. Maximize the energy efficiency. These are the low-hanging fruits that can be achieved. Then increasing the utilization of scrap. Then promote RD&D and set up pilot demonstration projects. Then stimulate demand for low carbon steel. Maybe in premium projects, maybe in premium cars. Then policy and regulatory framework to achieve these targets. Then in energy efficiency, BATs can reduce energy consumption by 10 to 15%. This has been identified in task force also, that it is a potential of integrated steel plants, as well as the potential is more in SSIs. Then these are the low-hanging opportunities. It can be adopted as short-term measure in all the steel plants. Best available technologies. For example, in integrated steel plants, dry punching technology, TRD, yes, re-heating furnace, or scrapping the ingot root process altogether. Right? If somebody is following that, so these kind of bags, or now strip casting technology is available in the market at commercial scale. So Prime Metals has that technology. So these kind of technologies, various technologies, waste heat recovery systems in DRI plants, and so on. Then this is the energy consumption that we found in integrated steel plants. 6.5 gigacal per ton is the standard in Indian steel industry average energy consumption. But with the BATs, we found that 1 gigacal per ton of crude steel can be reduced easily. Tata Steel is the energy consumption in Tata Steel plant we found was 5.3 gigacal per ton of crude steel, while in SAIL it is around 6.3 to 6.5 gigacal per ton. And similarly in DRI group, it is further energy consuming process. The average energy consumption is around 7 gigacal per ton of crude steel, and it can be again brought down by 1 or 1.5 gigacal per ton of crude steel. With increase in scrap utilization, we can reduce all raw material consumption, lower logistics cost, energy consumption, as well as the CO2 emissions. So this is best possible way of producing low emission steel. Then of course these are at theoretical level right now. CCUS or using green hydrogen is a bit practical, but again MOE molten oxide electrolysis is also a lab scale technology, I can say lab scale technology. Then we need to have some PPP type of agreements between Government of India, private players or public steel players to develop a technology, and for decarbonization it will be a key step, because it will mitigate the risk. Then a suite of policies will be required for demand side and for supply side. Hydrogen route and CCS route are the, if we classify them for decarbonization, hydrogen route and CCS route are the two major routes that we have identified, maybe different combinations. Then
in CCUS route, how do you utilize the carbon?
see, one such utilization potential is in fertilizer industry for urea production. CO2 can be captured. If we are talking about green hydrogen, then green ammonia will be the basic requirement for producing green fertilizer as well. And combining ammonia with carbon dioxide molecules produces urea. And here we have a huge potential of using this CO2 from maybe steel industry or cement industry or whatever.
In green hydrogen, in CCS, the normal process which we are operating, how do we utilize the end product? CCS.
See, sir, that's what I am telling. See, if you see steel industry and fertilizer industry. Steel industry industry produces a lot of CO2 that can be captured. Either there are many ways of utilizing this CO2, maybe methanol, ethanol, or whatever products you can produce. But major potential is in fertilizer industry. In fertilizer industry, urea is nothing but ammonia combined with carbon dioxide molecule, right? In basic terms. So when you capture this CO2, bring it to fertilizer plant, produce urea, you will not need external urea. In the existing system in fertilizer plant, ammonia is produced from natural gas. CO2 is a byproduct. It is captured and utilized in the plant itself. But when you will have green ammonia, if we have green ammonia, we want green steel, but we also want green fertilizer. So we have green ammonia. We can take carbon dioxide from steel plant, and then we can produce green fertilizer. So steel industry is also green by CCUS, and fertilizer industry is also green. So this is a one big potential that has been identified.
Is there any potential for graphite making a?
Sorry?
Is the potential of graphite, is there any potential opportunities in India?
Graphite making?
CCUS.
Of course, they can be explored. I'm not aware of this. If anyone has taken that initiative. But if it is so, then it is good. It is also another opportunity.
They make it into some kind of pellets, small pellets. What I read here. From CCUS, when it is captured, then it is like converted into some sort of pellets or what?
No. It is converted to dry ice.
Dry ice.
And then stored into PMC beds or whatever the safe storage potential is there whenever. So that it reacts with some material and form unreactive salts which are safer to store.
Do we have any project that has been already implemented at the scale?
In India, it is not there. In Scandinavian countries, it is there. Norway government or Sweden, they have put in a lot of money into that, and they are storing CO2. But in India, assessment is going on that what is the potential of storing this CO2 across various locations in the different zones, right? In the seabeds or the Yamuna beds, whatever. It is being assessed.
What is the cost of capturing per ton of CO2?
Right now, we interacted with few companies, few startups who have CO2 capturing units, and they say the OPEX is around 20 to 30 USD per ton of CO2.
Operational cost.
OPEX, yeah, operational.
20 to 30
$20 per ton.
Per ton of CO2.
Like the capital cost.
CAPEX is around I don't remember, but it is in few crores for a 1 ton unit.
So like
Something like that.
economically, will that be viable to produce Euro or anything?
What is the cost of
What is the cost?
installation?
Sorry?
What is the cost of installation?
CAPEX. I think forgot the figure. I can share it with you, but it is few crores for a 1 ton unit. It's a modular unit.
That is capable of capturing how much CO2?
1 ton scale projects. These are modular.
1 ton
Per day or per month?
Per day.
1 ton per day.
These are modular units, so these can be stacked and utilized as per the startups. And few companies are there like Indain and all, who are doing much.
Indain.
I'm not aware if they are into CO2 capturing, but clean tech is there.
And then at present, I think the cost of capturing, the cost in production of per ton of urea, in that the cost of capturing carbon will be more than the present price of urea itself. At present, I think.
See, in all the plants, in most of the urea production plants in India, CO2 capturing is integral part of urea production. So, CO2 capturing also needs some energy. A lot of energy is required. And in ammonia production process or in urea production plant, there are a lot of reactions which are exothermic and there are a lot of things which are endothermic. the costs are less. But when we interacted with the industry and the domain experts, we found that if we take green ammonia and if we take captured carbon and producing urea, then the chains have to be optimized accordingly. It will be not as same as the current production process or manufacturing process of urea. So you can see the green hydrogen. If we use green hydrogen, how it compares, the cost compares. See, we use green electricity. Of course, it is not at all viable. With the renewables, there is a better possibility. And natural gas has hydrogen produced from natural gas has much more potential to be utilized in hydrogen-based steel production. And again, coal, the cost is high. This natural gas or syngas to play a transition role, as I already mentioned. JSPL is having syngas-based plant that is unique in the world, but their emission intensity is a bit higher than the current steel producers. Recently, coal is converted to syngas and then it is being utilized for DRI production. So, although in the short term the emission intensity may be higher, but it could be a risk mitigator for long term. Then green hydrogen is available, then these furnaces can directly switch to green hydrogen based DRI.
The whole story starts when green hydrogen is available, isn't it?
Yeah. Yes. Yes. And a cheaper rate, of course. Of course. Then the decarbonization levers for 2017, we did an analysis how things will move on in the current scenario with the policies in mind, with the interaction with the stakeholders, industry, research institutions. We found that the green hydrogen has the most important role to play in India's decarbonization, steel industry's decarbonization. Then CCUS again, we are expecting that capturing efficiency will attain the optimized level by 2040. Then circularity, it means increase in scrap share. Energy efficiency, it's a short-term measure, but it will be fourth in the potential. Then electrification and new technologies. Electrification, we are not saying that it will kick off immediately, but we can expect few projects to be of commercial scale by 2050 or so. Then material efficiency means we will reduce the steel demand by creating some better alloys. Like these days, even 650 grade steels, 650 MPa grade steels are available compared to 10 or 15 years before, when it was the strength used to be 450 MPa. Consumption will be less, right? So this is we are expecting that this is going to play a significant role in decarbonization of steel industry. So this is a summary of decarbonization levers, how the technological scenario will change in each decade.
What is the
Can you go back to the previous slide? By industry by 2070, current emission of 272, that is million ton.
Current emission of CO2 in steel production.
Total India's emission?
India's total industrial emissions are around 1200 MT.
No, I mean total India's.
India's total will be around 2500 MT million tons CO2.
Per day.
Sorry, 2500 million tons of CO2 per annum.
500 million ton. It's almost 2.5 billion ton.
Yeah.
So 2.5 billion ton, steel industry is 272 million ton. So what percentage is that?
11%.
10 to
11%.
10 to 20%, but the general figure revolves.
What is the biggest contributor?
What?
Which Which industry is the biggest contributor?
Of course, steel.
Not the power sector.
See, power, in the power sector, there are two things. First, whatever power industry is consuming, and the power domestic sector is consuming. So, if you will combine all the power together, of course it is the biggest contributor, but if you will divide it into domestic and industrial sector,
No,
then
so 3 billion ton is everything, right? 2.5 billion.
it's a way of seeing things, right? Whatever you are saying is right, whatever I am saying is also right. So, it's a way of seeing the things, whatever you are saying is also
So
right.
what is the percentage of power sector?
See, I can't remember right now, but yes, we have reports, daily reports, you can refer those and you can find those numbers. This is the technological scenario. I think in 2017, scrap EAF, then EAF, EUF rule will still be there in CCUS, and then molten oxide electrolysis or electrolysis process will be there, and hydrogen based DRI will be a major share of steel production. The challenge is again low TRL levels of these technologies, low penetration of existing low carbon technologies, high capex and opex of newer technologies. This is the reason the industry is expanding in blast furnace. So lack of ecosystem and infrastructure. If we talk about hydrogen, then this is a challenge. Then high cost premiums, of course, cost of capex and opex contributes to this. Then lack of net zero policy mandates and standardized definitions for green steel or green products is not there. Although this has been taken into consideration by various ministries, including Ministry of Finance, because of this budget in the current year, they are aiming to define the low carbon products. And I think these challenges are well taken up by government, by various ministries or various departments. In the coming time, we can expect that things will change. Then key messages. DRI, hydrogen-based DRI is the most promising route. With the appropriate policy support, we can achieve net zero target by 2070. And yes, there are significant first mover advantages for some companies where the government mandates green steel procurement in government projects, and the results will be India will have globally competitive green steel market.
Generally, they say that advantage is second mover. Second mover is an advantage because all the trials and errors are eliminated by the customer.
See, if the risks are mitigated, let's say by government funding or a pool of funds is created by investors or philanthropic organizations, then of course they have first movers advantage. Whatever the technical know-how the first movers will have, I think the second movers don't have that advantage.
Those things that can be anticipated, that can advantage be reached by the customer.
See, it's a perspective. One has to be a first mover, right? So there should be a motivation for being a first mover. Second mover may have advantage. Let me state an example. Whatever the steel production legacy or the steel production technical know-hows Tata Steel has, JSW is yet to catch. And I'm not talking about SAIL because SAIL has a different work culture and.
I think it's
See,
a
I
bit
think
of
there is a
contradictory
I think there is a
statement,
scope to review your views.
Exactly. I was
In 2013, we are the first movers. We have put DRI EAF with syngas of 4x, which is the most energy and environmental friendly technology. What premium government has given to JSW?
No, sir. The thing
In
is also
2013, before these documents came,
No, you are right.
we are transitioning
this is
into
actually
S2
I think
S2
that
DRI.
statement because
There is no commitment
Tata
from the
Steel
government.
produces steel. If you talk about the if just talk about the blast furnace technology, Tata Steel produces iron in a much more comfortable position with respect to raw material. JSW Steel does not have that competency to handle to get that kind of raw material. So that statement I think needs to be rechecked.
JSW can't.
No, my statement is that JSW is at par with Tata Steel.
I think you should have better knowledge and understanding about what is going on in India first.
Sir,
Yeah.
sir, you are also
Please
right.
check. Please check the facts.
No, actually, I think
I
you need
think
to check
Tata
your
Steel
statements.
has installed much larger.
What is that?
Than JSW.
What is that?
No. That
Tell
is
me what is the Tata Steel
capacity
has
what
done.
is we're talking about. If you just talk about technology, know-how, Tata Steel and JSW is at par right now. You just can't say that Tata Steel is better right now.
ये trial ले लिया बहुत हो
Because we
गया.
are Indian industry.
There's a small trial of COG injection into the chairs. You claim that it's superior. We have got 800 megawatt renewables touching JSW Vijayanagar.
I am not saying.
What is the status
that
of
the
Tata
debate
Steel?
started from first movers or second.
JSW is the
No,
best.
but just
I'm not saying JSW can't JSW will be. I'm saying that I agree with you. The way JSW, the aggression JSW has, the Tata Steel does not have that at this moment. I know, I agree with you. The way trials are being done, the R&D initiatives, the investments being made by JSW in everything. I agree with that. Tata Steel is not doing that right at this moment. I agree with that. But if we talk about 5 years back, then of course Tata Steel.
statement is for today, not 5 years
Okay.
back.